The first part of this video is just going to be talking about domain and range. Domain is the set of all possible inputs or x values. So an easy way to remember this is that the domain ends in in, and inputs begins with in. And of course, in math, when we talk about relationships, inputs refer to just our x values. And when you look at a graph, right, the x values are going to be seen on the x-axis, which you read from left to right. Another way to think about it is just that if you're going and looking at the numbers, we're also going to go from least to greatest. So we just want to list our domain from least to greatest. So we look from left to right. The opposite of the domain is the range. And the range just represents all of the possible outputs or y values in a relationship. So if the x values go in, the y values come out. On a graph, we're going to read the range by looking at the y-axis. So we're going to look from bottom to top. So we'll measure the numbers from the bottom to the top of the graph. Or you could say we're just doing the same thing as domain, right? We're going from least to greatest. So let's just look at an example. So here we see a graph. You can see the curve there, which tells us that it's exponential. So it's just going to go up forever and down forever. And it says, what is the domain of the exponential function shown below? So domain in your brain, you should focus on the x, right? So I'm just looking at the x-axis and I'm reading the line from left to right. So on the left side, I see that there's an arrow on that graph. So that arrow is just going to go on forever. So it's just going to keep going down, 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 down. So numbers are going to go from -1 to -2 to -3, right? We can't even see all the numbers that it's going to continue going to. And then on the right, if we look up at the top right part of the graph, we see an arrow as well, and that arrow is kind of angled. So what that tells us is it's going to go up and to the right forever as well. So when we write the domain, we could say that it goes from -infinity, which is going to go down forever, all the way up to +infinity. And so x can be anywhere in that space. So from -infinity down to +infinity up. So at that point, you could just basically say the domain is any number ever, right? So all real numbers is what you would see. So building on that, if we just change the prompt and we start talking about the range, right? So nothing's changed about this problem in terms of the graph or the domain, right? Because it's the same problem. But if we say now, what is the range for this exponential function? The difference is we're going to look at the y-axis. And we're just going to see where does the graph start and then where does it go up to. So from the bottom to the top, right? And so I look at the bottom and I see that that arrow kind of isn't really going down, like it's subtly going down. It's just barely going down. And it's almost like hitting where the axis is, right? So where y is 0. And so because of that, we would say that this graph has an asymptote at y equals 0, which means that the curve is going to go, and I'll just kind of show you the curve, right? So if we go from the top and we kind of go down like we're going down a slide, right? It starts to flatten out. And basically that line is just going to go on forever, but it's never going to cross the y equals 0, right? It's going to go up forever, and we can see that. So it's going to go up towards infinity, but coming down, it's just going to get close to 0, but it'll never actually touch, right? So you could think about it like, what's half of $1? 50 cents. What's half of 50 cents? 25 cents. What's half of 25 cents? 12.5 cents. What's half of 12.5 cents? 6.25 cents, right? You can keep going down, but eventually you'll just have really small amounts. You'll never actually run out if you just keep halving something, right? And so that's the same thing with this line. It's just going to go down forever. And so because of that, we could say that y, basically the bottom value is going to be 0. Y will be in between 0 and infinity, right? So y is between 0 and infinity. And at that point, you could just say that y is always going to be bigger than 0, right? So there is no top border. It just is infinity. The bottom border is 0. So y is greater than 0. Part 2 of this video is going to actually look at more examples and show you where these graphs come from, but I hope this helped.